All right, let's get started. Welcome to the webinar, everybody. Today we're going to be talking about making off-grid systems smarter through data monitoring and communications. This is a joint webinar between RFI Technology Solutions and Morningstar. RFI has been a Morningstar distributor partner for 27 years, and we're very proud of that. Let's go ahead and take a look at the next slide to share some quick information before we start. The webinar presentation will run for about 30 or 40 minutes, and then we'll answer any questions that you text to us in the question chat section of your GoToWebinar console. We have attached a copy of the webinar slides that we're using today, and you can download that from the handout section. And a recording of this webinar will be emailed to you tomorrow. Now let me provide a 30-second overview of Morningstar before I hand off to today's presenters. Morningstar has sold well over 4 million solar charge regulators and inverters since our founding in 1993. Our products are used in over 100 countries for mission-critical applications, including telecom, security, lighting, RV caravan, marine, residential, rural electrification, and many others. Morningstar has the widest charge regulator line and the highest reliability rate in the industry. Now, with that said, let me introduce today's presenters. From RFI, we have Monique Merino, and from Morningstar, we have Brad Berwald. Monique, I'm going to ask you to take yourself off mute and go ahead and start the presentation.
Good morning. RFI started out in 1979 as a really small manufacturer of radio antennas, and Steve managed to grow that really well, and we started to specialize a lot more into especially remote communications and remote coverage. And at that point in the early 80s, we really started to see off-grid capabilities and being able to provide off-grid power as a really important part of our business. And so we brought on at the time solar panels and regulators to be able to supply not just the coverage, but also the power side of that solution. We then continued to grow over the years, and we're now exporting both of our antennas, our rebroadcast gear, our solar to over 90 different countries worldwide. And we've got 3 manufacturing sites across Australia and 4 offices. So we've really grown that industry out. And from the beginning, when we first started solar, we really saw that having high quality, high reliability product as being a really important part for these remote sites. So when Morningstar came along, we saw them as a really good partner because they really shared those values of having highly reliable, high quality regulators and solar controllers. And so that partnership has continued today for 27 years, and we're still using them in a lot of our off-grid and remote capability solutions for coverage enhancement and really ensuring we're getting remote coverage and remote enhancement. So we've really become specialists not only in antennas, but off-grid power, IoT for off-grid as well. So I'll get you to move on to the next slide, Brad. So today we really want to talk about why monitoring is really important in these off-grid sites, but also how Morningstar and RFI can ensure we can get you connected and make sure you can stay connected and really control and monitor these off-grid sites. So of course, one of the major benefits of having monitoring is being able to see the health of your system. So one of the major things we always want to make sure that we protect is our batteries. So often in these off-grid sites, they're one of the more expensive assets. And so they're the ones we really want to get the greatest longevity out of to make sure we're really getting good return on investment. So being able to remotely access and remotely see things like state of charge, whether or not you're undercharging your batteries, if you're getting to the right charge point each day is really important. Being able to get alarms on state of charge to say, do we need to disconnect these batteries? Do we need to start activating some genset to supplement those charges? Do we need to think about putting in a generator onto that site to make sure that we're getting to that charge point every day is really important. Especially as well as we start to see more lithiums in these sorts of more remote sites, but also in more extreme sites, so such as snow covered, it's really important that we're getting things like temperature and temperature alarms as well to make sure we're using our batteries in appropriate areas. And so getting those sorts of alerts are really going to ensure that you're getting longevity out of your system, but longevity out of those really expensive assets, such as your battery. So the other thing we generally want to make sure we are protecting is our load control and protect. So they're often the other really major assets. So they're the things that you wanted to run in the first place. That's what you're getting your return on investment on your site for. So being able to do things like choosing low voltage disconnect overrides to make sure you're protecting or keeping your load on for as long as possible. So if you do choose to sacrifice your battery slightly to make sure that load's staying on, or being able to set primary and secondary loads on that site and sacrifice those secondary loads in order to make sure you're keeping your primary up for as long as possible. And then just being able to monitor your system in general. So, are my panels operating optimally? Does it look like there's damage on the site because one day I went from full stated charge every day to the next day my battery is no longer charging and there's no good reason due to weather that it wouldn't be? Is there an indication there that somebody needs to go out to site and replace a portion, replace something on the site? So monitoring is really important to make sure that we've got visibility on our site, that we're connected to it and we can see what's happening without being able to actually go out. So in a lot of these places, they're highly remote. Going out to site is really expensive. It's a lot of labor, it's a lot of time. So being able to cut out that travel time, being able to reduce those labor costs and achieve all of those aspects remotely is really important to getting the best return on investment you possibly can out of these remote solar sites. So I'll get you to go on to the next slide, Brad. So leading on from that, remote monitoring can have huge impacts. So not only are you getting that better data management and better predictive maintenance out of those sites, you're able to pull that data out to make informed predictive maintenance schedules. So it's not just running off of a schedule, we go out every 6 months. It's we know we need to go out because we've detected a problem or because there's something that seems to be a little bit off on this site. We're also able to collect that data into desired endpoints. And this is a really beneficial thing that Brad will go into a little bit later with Morningstar in particular. With it being so flexible, it's really easy to get that data to whatever endpoint you want. So if you need to be integrating it into something like Eagle.io or your other major monitoring platform, it's really easy to get that data to flow into one central endpoint, which really minimizes the amount of platforms you're using and it maximizes your return on investment overall because you're getting that data out to a central endpoint. Your major benefit then really becomes that faster fault resolution. So getting things like automated alarming, which we'll talk to a little bit later in a bit more detail, being able to do remote fault analysis, so being able to log on to your system, see exactly where the problem's laying, being able to use that data to detect what could be wrong or what is wrong in your system remotely without having to go out to site, being able to monitor those aspects and diagnose all of those aspects from the comfort of an office without having to go out to site. And that then really ties into what makes remote monitoring really cost effective and how you get such high return on investment out of putting things like modems and monitoring onto your sites. So it really leads to that lower system downtime because you can get those faults removed a lot faster. You can get that resolution a lot faster. You're really lowering out your labor costs because you're not having to go out to site as many times because you can get that analysis done already. You know what's wrong with the site before you can go out. So you're being able to take the correct replacement parts or the correct gear with you when you go out to site. So you're minimizing the amount of time you need to spend, but also the amount of site visits you're needing to do. So it just makes that whole troubleshooting and replacement and fault resolution a lot faster, a lot easier, and it means you can maximize your asset and meet all of your SLAs down the track to wherever you need them to be going. So I'll hand over to you, Brad, now to talk more to how Morningstar's system in particular can help us achieve these goals of remote monitoring.
Okay, thank you very much, Monique. And I'll move on to the next slide here. Thanks for the introduction. And I just want to say, again, my name is Brad Berwald, Senior Product Manager at Morningstar. And you know, when I started at the company 20 years ago with Morningstar, RFI was already an established and very experienced customer of ours in an industry that's very dear to me in telecommunications, you know, a very unique specialty and a longtime user of off-grid solar. So glad we've been able to continue that relationship throughout my entire career. So thanks for that. And thanks for joining us today in this collaborative presentation. So with that, I'll talk a little bit further and get into some of the products. This is an exciting topic on monitoring these sites remotely. One of the things I wanted to pick up on and to continue to discuss beyond all the benefits that Monique just talked about is that when you really get good data, not only do you have the benefits of enhancing these systems and improving them and optimizing them and reducing costs and downtime, but you gain a really detailed understanding of how the system is performing, not just with big numbers like kilowatt hours and battery voltage, but really usable trends over a day or a week or a month, even year-to-year seasonality to see how a system is performing during that same season with the same level of sunlight year after year. With off-grid systems, they last quite a long time, and batteries are lasting even longer now, especially with the transition to lithium. And you really gain a lot of insight into how you can improve the system, how you can understand them, how you can predict those maintenance intervals or even potential failures that are pending. So in this example here, I just wanted to show a little bit about, when you really get that data, this was an example of where we logged not only the consumption of watt hours of a load, but we also monitored the peak power. So it was actually showing not only the consistent draw, but also the spikes that occurred during momentary loads that such as actuation of valves and motors that just ran for a few seconds. But we saw that the peaks were much higher than we realized, and that was really insightful in understanding more about how the loads were actually operating. So a little bit to divert here a little bit, what we're seeing in 2022 is a lot of connectivity, and RFI is unique in that, critical needs for energy and telecommunications are both areas of expertise of RFI, and that's excellent because that's a lot of what solar is doing, and the need for data along with those solar sites is really becoming almost a necessity. And when you have the options for connectivity, you're seeing that a lot of solar controllers, namely our own, they bring a lot of industrial connectivity built in, even the small ones now. They are very sophisticated products, they're very intelligent, and having a standard suite of communications, even Ethernet, down the product line, even to low power systems below 20 amps is really getting common now. Also in the industry, you've got extensive connectivity options. You've got, LTE coverage has never been faster, cheaper, and more sophisticated. And the network's very diverse and, ubiquitous around the world. And that's a great thing because the coverage is there. Satellite connectivity is changing rapidly, as we know from many vendors. And also you've got these newer, lower power, they don't move a lot of data, but they have extremely good range and they're extremely cheap. I mean, in some cases, practically free with the product that just give you a command of on off or a simple sensor reading those low power wide area networks. So all this is adding up to good things for solar connectivity and solar power. And also many applications already rely on data to provide the actual features of the load itself. And that speaks to security, such as video cameras that can easily transmit video over LTE, larger telecom, cellular base stations, and of course, sensor and telemetry networks as well. And this is accomplished through some protocols, SNMP and Modbus, featured on the right there, and I'll go into more detail into those in a little bit. So some of the monitoring products that we are going to feature today, many of them do support monitoring that we offer, but two that we want to uniquely focus on here are our TriStar MPPT and SunSaver MPPT. So first, the TriStar MPPT, probably the flagship of the product for now, as we have many more exciting things coming from Morningstar. but the flagship product now has applications that cover telecommunications, residential, industrial, transportation, such as railroads, even marine applications. Comes in a 30, 45, and 60 amp charge rating, 3 different models. All of those support 12, 24, and 48 volt units in a single model. Well, of course, we have lithium compatibility, and we see that being adopted rapidly. A 150 volt maximum open circuit voltage, so that we can handle a lot of the newer models of modules that are coming out as the cell technology continues to improve. A bit of a unique feature of these products is the ability to oversize the array, meaning you can put a substantially larger amount of power on the controller than it's rated for, and the controller will clip that and just run at full power with that straight 60 amp output continuously. And it's sized in much the way that a lot of grid tie inverters are sized, with their DC to AC ratios, and you can now take advantage of that in off-grid. So it's an extremely beneficial feature, and one that we're proud of, because we will very tightly control that power. We will not trip that output circuit breaker or fuse because of this regulation, and you'll know that this is a feature on all of Morningstar's MPPT controllers. And then going further down, meter display options with parallel capabilities, which I'll be discussing. Onboard serial and Ethernet standard on the 60 amp, and optional on many other products using our EMC. And of course, our TrackStar maximum power point tracking algorithm that has a lot of unique advantages. It's not a chip that we acquired from another company. It's not a software license that we just decided to purchase. It's our own MPPT algorithm that we designed ourselves and embedded in every one of our microprocessors. And we think there's a lot of reasons it's superior, because we had a big task for it in terms of efficiency and speed and performance. So we're very happy to have that in all of our products. Even the SunSaver MPPT, a much smaller model, has the TrackStar tracking algorithm. Its applications also include many similar, but also mobile and marine, smaller telecom systems, little point-to-point radios, not so much cellular, but the smaller systems, which are growing in volume immensely, industrial, security, and transportation. It has 15 amp charging and 15 amp load control, 12 and 24 volt batteries, lithium compatibility, of course, a lower but still highly useful 75 volt open circuit maximum input, an array oversizing capability as well, our meter bus port, and of course the TrackStar technology. So just a brief overview of our products, but moving more towards our monitoring and parallel systems that we wanted to discuss, there's a few other accessories that work with these products, namely the TriStar PPT, that bring a lot of value. One is their TriStar Meter 2, that is the standard product for the TriStar MPPTs. Displays not only the controller data, but also aggregates the data of all the TriStar MPPTs together in a single meter. So it shows you collective, all the charging together, battery voltage, all the loads combined together, for up to 15 devices. So it's very powerful, because the TriStar PPTs, it's unique having that redundancy of each controller is independently operating. So you have a little bit more, preventative reliability, because if anyone fails, the others continue to run. And we've seen as many as actually more than 15 in a single system. I know it sounds quite large, but it's they do exist, and it's quite impressive to see those wired up. But multiple TriStars, 2, 3, 5 at a time, is very common. Our meter bus hub then on the upper right corner there is what then gives the ability of the TriStar to communicate with all those devices. And you can add them in groups of 5, 10, 15 as you scale the system. And it provides not only that communication and networking capability, but also isolation, because it needs to ensure that you don't have any current flow. So they're actually optically isolated. It allows data, but not voltage, and that ensures that you don't have any grounding problems, especially in telecom, where positive grounding is a very common application, and one which we're extremely compatible with. The Ethernet meter bus converter gives the Ethernet capabilities that's common on the 60 amp to any of our other products that have the meter bus port, SunSaver MPPT and others. So you can gain that Ethernet capability because it's very popular. People want IP connectivity, and they want to be able to reach those sites remotely. And then lastly, the relay driver, which we'll be seeing in a little bit of an application later on, but it gives you 4 individual contacts for relay controls. And these aren't just signaling relays. They can actually drive 3/4 of an amp on the coil. meaning we can switch 60 or even 100 amp, very large, current handling relays that not only drive power, but also, can signal alarms and faults. And there's 4 of those, which can also act as voltage inputs. So it's a very capable device, a very flexible one. And in my time in specifying systems over my period of work and supporting various applications at Morningstar, I find that this product is the one that really solves a lot of unique problems. So, okay, so going forward, a few comments about parallel systems, and just want to touch on a few topics here. When the TriStar PPTs are used together, they're connected with the meter bus interface and the hub and the meters. All of the charging stages of all these controllers, in general, since they're all looking at the common battery voltage, and they're very sensitive in terms of their voltage accuracy, will transition together. So they'll go through your bulk, your absorption stage when it reaches full, and then all gradually transition to float. They won't always do it at the same time, but that's fine because the battery it doesn't always need all the current of all controllers. You'll kind of have several of them slowly transition into those stages over time, and that's usually fine because you're limiting current anyway at that point in absorption or float. The battery is pretty much finished with its charge. The amp hour charge throughput, varies a little bit across devices depending on the wiring and the distance they are, but each controller is operating independently of the other. So they are not required to all be working. And if one were to shut down for some reason, you have a high degree of redundancy, or N+1 is a common IT term that shows that you have more units that can back up those failed systems. So it's a very common platform to use several of them. Data is combined using the TSM2 and will aggregate everything on a single screen. However, you can also individually look at the controllers one by one if you needed to look at them for specific diagnostics of just that controller itself. The hub, as I said, adds that expansion capability and isolation while allowing the data connectivity. And up to 15 devices, I did the quick math, and that's around more or less 44 kilowatts of power in a single off-grid system. So a very, very large one at that, definitely pushing the limits of a 48-volt battery, but definitely can get the job done. So in looking at system cases where you're looking at a need and you've got to design a system using the TriStar and its family of accessories, what types of questions do you typically ask? First of all, what is the application? Are there any unique features or needs of, say, telecom or mining or telemetry that are a little bit different from the others that would require a certain data protocol or a certain type of battery? For instance, we see nickel cadmium batteries used occasionally in telecom. It's a premium battery, a bit costly, but has really unique attributes. We can support those. So those are the types of questions that you ask. And then in terms of the requirements, how many controllers do you need? How will the array be sized or oversized on those controllers? What type of battery type and charge settings do you need to configure? Is it a default setting inside the controller? Is it one which you can customize yourself, which the controllers can all do? It's incredibly flexible. The data for remote monitoring, how will you connect to the site? A point-to-point radio, such as used in mining, will you use cellular using a public network? How will that modem be integrated, and which modem will you choose? And Monique will talk about that from RFI a little bit later. And then exactly what are you monitoring? Everyone says, well, battery voltage, is the tank full or is it empty or somewhere in between? There's much more to it than that, because there's temperatures, there's charge stages. When was the last equalization? What was the depth of discharge or state of charge? There's many things you can learn. And then lastly, how will you be notified if something happens at the site? Will you be notified quickly in time to take action and to get to the site if needed, or start a generator remotely, or change the way in which your loads consume power? You may be able to dial back some capabilities while you make sure that the batteries are restored. So these are all critical questions. And in this example, it's a bit of a complicated one, but the reason I wanted to bring it up and just draw illustrate some concepts here is because in this case, we've got one-line diagrams that represent power. We have IP Ethernet capabilities. We have Morningstar's meter bus connections. We have our temperature sensors. We have 45 serial network as well, running alongside the Ethernet. And then of course we have these auxiliary relays that are being acted on. And remember that there are, in the handouts file, you can download the presentation, and this is probably one of those slides that you'll want to take a look at much later in more detail. So I'd recommend taking a closer look, and you can actually see a lot. But just as a brief overview, I'll go through this a bit quickly, but you've got many TriStars accomplishing different functionality. Load control could be used for diversion. TriStar MPPTs providing solar charging from the array. You have the ability to integrate all of the TriStars through just one meter, which is not only easy to do, but also cost effective. You've got the hub doing its job, as I explained earlier, connecting all those devices together. You've also got the relay driver connecting to these systems, and then it has the ability to control relays for alarms or load control, as well as potentially start a generator, and then all that being interconnected. Now on the data side, you'll see that we have the internet connection here. Only one of the controllers has Ethernet connections in this instance. That can change. However, what's unique is that all of them are connected with an RS-45 serial communications link. And what's really useful with the TriStar MPPT is that it can actually share that Ethernet connection across the 45 bus to those other devices. Even though they're not Ethernet enabled, they might as well be, because they are actually able to be reached by IP-based internet devices through Ethernet by using the TriStar PPT as a bridge. So this is a really cool function. Again, reduces cost and enables better simplicity. You can add Ethernet to the other products if you wish, and there's examples of when you may want to do that. But in this case, it's a very efficient design. Okay, so that kind of represents probably a more elaborate system that encompasses everything, but that is the point of this webinar, to kind of show you the possibilities of what can be done for data, for relay control, and for connecting devices to each other. Okay, now here's a quick shot of if you did want IP connectivity and you wanted to use Ethernet for everything. And in a lot of networking instances, they do, especially with security and small telecom. They've got switches right there in the cabinet. You can use an Ethernet switch and you connect to all of those TriStar PPTs, or even other controllers that have the EMC, which adds Ethernet capability to them. Now, the data protocols that are used with these connections, mainly the IP connections, they come in 3 different categories, and I'll just give a brief overview of what those look like and what they do, and when you might want to choose one over the other. So the first is HTTP. It's the web standard. Web pages use it. HTML, it's the same category. And it's the easiest and simplest because any device that has a web browser, including a mobile phone, Safari, Chrome, you name it, can connect to that web page and actually look at a simple dashboard that will give you that data. So it's handy when you don't have any kind of device connection set up, you don't have a lot of elaborate routing and networking amongst the controllers. You just need to see what that one is doing. You can do it easily and with no software, just a web browser, which is on every phone. Now, Modbus monitoring Modbus is an industrial standard. We have an extensive list of data, dozens and dozens of values and variables that can be pulled from the device using Modbus. Maybe even a few you weren't aware of, even diagnostic codes that we use ourselves internally at Morningstar. It's an open industrial protocol. It's very robust and fast. It is a standard in many other industries as well, including SCADA systems used in oil and gas and mining. And the nice thing about it is IP-based, which means it can move over any kind of packet-based network, satellite, cellular, point-to-point, you name it. And then lastly, we use one called SNMP, which stands for Simple Network Management Protocol. That is very similar to Modbus, but it's of a different flavor in that it would be very common for you to use SNMP if you were already working in an IT environment. So if you were doing communication systems or cellular connections, you might already have SNMP monitoring in place for your networking equipment. It's really common for switches, hubs, and computers. And therefore, if you're already using that with the network management system, you may wish to choose to add the solar controllers and the energy data right into that same system. And that's really why we did it, to make it easy. Just kind of merge that data. You can all see it on a single pane of glass, as they say, and it just makes things easier. So here's an example of the live view dashboard. It's a quick glance at an HTML web page, gives you the basics, and can be available in the TriStar PPT natively or in any device that has the Ethernet added to it. Here's an example of Modbus data, and it's not a dashboard. In this case, you're looking at a very high resolution, very granular log file of 3 days, the life of a solar system across 3 days. And you can see the amount of detail that you can use Modbus for, because you can change the polling interval. It could be once an hour, once every 15 minutes, could be once every 5 seconds. We even have a lot of universities and other educational facilities use our products because they can log data to such a high degree. It's an excellent educational use for their solar energy programs, and we get a lot of requests for them, and we're happy to do that. And it's because of this technology with our free software too, and built-in data. You know, they don't need a sophisticated data logger. And then the last being SNMP, as I explained, one of our partners in our data partners that came on and started working with us is a very popular network management system called Zabbix. And Zabbix does these types of IT networking, and that's all they do, and it's very extensive. And they created profiles and presets and templates to bring our products into their tools in a very easy way. And you can see on the right some of the elaborate graphing capabilities and dashboards that can be built that include networking as well as solar energy data. And on the bottom, you know, a very nice diagnostics page that shows status of many different devices and their conditions, you know, with the green icons. So yeah, a very interesting application. So with that, that concludes my portion of the presentation. So I will actually refer back to Monique so she can take over. And now that I've given you a little bit of the product background, she's going to go specifically into these use cases and applications where she's put these products to use in the field to solve customer problems. Okay, so with that, I will hand things back to Monique. Thank you very much.
So building on what Brad was talking about, it's all well and good having all of these dashboards and being able to log in and see everything your system's doing. But for a lot of these mission critical applications or anything where you really need that system to be online, you really want that alert right there in that second when it's happened, to then be able to fix it as soon as possible to make sure you can get your system up and running again. So that really begs the question, how and what is the most efficient way to get those alarms to the correct people to then be able to actually act on it, to log into the dashboard, to then see, you know, what else is going on in the system. Do we need to go out to site? Are there other steps we need to take? Do we need to turn a generator on right now to keep our system up and running? So one of the ways we can do this is through the Morningstar relay driver paired with a modem or a PLC. So Brad was talking about the relay driver and how it can be used for alarms as well. So it's got two I/O channels for alarming that can take and be programmed for a whole host of different aspects, from the regulators, so state of charge, your voltage, temperature alarms. There's a whole host of different things that can be programmed for on those two channels. So that relay, it's just a I/O circuit, so it can be used to drive an I/O on something like a modem or a PLC, and then that, depending on that digital input or that modem or that PLC, that can be used to then alert somebody in some way, shape or form. And this is really where RFI comes in, because we do have such a host of modems and other IoT products. We've got that perfect interaction of being able to then provide that backhaul and to provide that modem that can then drive and message the person. So I'll get you to move to the next slide, Brad. So how we can automate with our products. So if we take, for example, our MA2080 modem, so this is our universal hub modem. So it's a nice little compact unit. with a fairly robust and flexible I/O capability. So it can be used to trigger both SMS and email notifications off of the I/O. And so it's really simple to integrate into that system. So you're able to connect that up on the relay channels from the relay driver into the I/O, and that'll just be a really simple twisted pair. They're all screw terminal Phoenix connectors, so really easy to connect up in the field or when you're testing it back at the office. So whatever that alarm is, whatever that fault is that's been detected by the TriStar or the regulator on the site, that's then able to be triggered into the relay driver. Depending on how you've customized your relay driver and how you've programmed it and exactly what aspects you've asked it to monitor or alarm on, it's able to then take that signal, send it out through its alarm channels, so through its digital output channels. It's then able to activate that relay circuit in our universal hub. And then depending on how you've programmed your universal hub, it's able to send out either an SMS or an email with a message to any desired contact. So it can be one person, it can be a whole group of people, and that then allows them to, as a human, take ownership of that problem, be alerted of that problem as soon as it's happened, and be able to take further action. So if that's logging into the system and getting a view of, this, we need to decide if we need to disconnect the battery or not, or do we need to protect the load? Do we need to go and turn a generator on now to make sure that our battery stays charged and our system stays up and running? Have we suddenly lost all charge, so we're not getting anything into the system anymore? Has something catastrophic happened to our panels? Do we immediately need to get somebody out to site to get this system up and running again? So it's a really simple way to get a immediate message out to a person to then be able to take action and protect your system. So I'll get you to move to the next slide, Brad. So the really good thing about not only our MA2080, but across the board for our modems is most of them do support some form of I/O. Specifically in the MA2080, we've really made it very easy to program these I/Os so that you don't need anyone with particularly high level IT skills. It's really intuitive in the way that we've written it. So it's really point, shoot, type it in. We've got a really simple GUI interface that all you really need is a computer with internet connectivity and an Ethernet cable to plug into your modem, and you're able to get this GUI up, and it's very intuitive to use. So to get these alerts going, all you really need to do is set up your SMS contacts inside of your modem. So that can be either, pretty well you need a name, either a mobile number or an email address, depending on how you want them to be contacted. You then set up a group for these people. So you can see here we've set up a group called TriStar Alarms that consists of 2 people in it, so myself and Neil. And then you just build that group. From there, you look at the setup for the actual basic configurations of the I/O themselves. You're able to customize a message, which is a really nifty feature in the MA2080. So not all I/O allows for customizable messages. So it means that we get something a bit more exact than just saying I/O 0 has been triggered. We're able to say pretty well up to characters in a single text message. So in this case, I've said TriStar alarm input 1. So we get a little bit more context for that message that's been sent out. So it makes it really easy to be able to be interpreted by people, not just machines. We've also, with this one, we're able to send a different message when the I/O is opened again. So for that off trigger, you're able to customize that message as well, which is really nice for being able to be interpreted by people. You're also able to customize and choose whether or not it's just going to go to the SMS group, or are we also going to send an email? So you can do them independently of each other. And then we're also able to change debounce time if it's needed, but that shouldn't be an issue for the relay drivers. The other little feature that we're able to do is basically an alarm reminder for the duration that that relay is triggered. So every hour we can choose whether a new message is sent out. So if we need to make sure that it's attended to and it hasn't been, or we can choose to turn that off if you don't need or want persistent messages. But it's a really easy setup. It's a really little extra thing that can make your system a lot more stable, a lot more useful, and it can make those alarms a lot more useful for interpretation by people. I'll get you to move to the next slide, Brad. So the other really useful thing about our modems is that it means you don't necessarily need another piece of hardware. So we're really covering off all of your communication needs in this one modem. So for both our MA2080 and any of our other modems that have that I/O capability as well, you'd be able to really use them as that communications hub for your whole system. So they're able to provide that internet backhaul. So they're all cellular modems with generally upwards of Cat4. So they're providing that high speed. They're able to handle everything on your site basically. We've got dual Ethernet ports, so you could put two direct TriStars or EMCs directly into that modem, or you could have it connected to, say, another PC there or another Ethernet asset on that site. So you could potentially be using it not just for running your solar system, but you could also be using it for another Ethernet Modbus or Ethernet application on that site as well. We also support full dual SIM redundancy on these modems. So if you have a really mission critical site where you need to make sure that you're always online, we're able to have a second SIM in there that can come online if you lose your network connection to your primary telco. It can then fail over to the second one, and the MA2080 has full redundancy, so it will check back and default back to your primary internet connection or your primary telco as soon as that network becomes available again. We've also got serial for 485 or 232 on these modems as well, so that could be used to interface into the Modbus serial ports for your solar controllers, or it could also be used for another asset on that site. So it could be running a part of your monitoring, or could be running a sensor on the site as well through that serial port. So it could be plugging directly into, say, your SCADA system and taking that functionality as well. We've also got additional inputs and outputs. So there's two full digital inputs, two outputs on these modems. So while you could be running your alarms from your relay driver on one input, you could be running a sensor or something for temperature on the second one. And you could also be running those outputs to then take action on something else based on that second input. So it could be running a generator off of that. You could be triggering a pump if needed. So there's definitely secondary applications that could be used on a site with these modems. The other really good thing for integrating in with Morningstar's range with our modems is that we do cover off a fair few different industrial protocols natively inside of our modem. So we support Modbus, TCP, and RTU, so both for serial and for TCP Ethernet. So it just makes that compatibility a little bit easier. It makes that integration with Morningstar a little bit easier because we're natively supporting those protocols from the beginning. So it makes it a lot easier to get set up, a lot less finicky, a lot less fiddly to get set up and integrated into these systems. But it really means that we're that communications hub for not only your solar system, but due to the flexibility in these modems, they could definitely be used for other applications on that site, other monitoring or other Ethernet needs on that site. Of course, as well, being a antenna manufacturer, there's also a lot of flexibility for the antennas that we'd be able to run with these modems. So we've got full ranges of very high gain LPDA antennas, omnidirectional antennas that we can really help design into your site and help advise on your site to make sure that you're getting the most out of your system, to make sure if you're in a fringe area that we've got that coverage aspect covered for you. We'll be able to advise, maybe we need additional things on this site, such as a cell file for your coverage enhancement or coverage boosting if you're on a really fringe area. So from our perspective, we're really able to get that integration of communications coverage and getting your power fit out that's been provided from Morningstar to make sure that we've got a really reliable site that can be easily monitored, easily managed, and that you can really get all of those alarms and automation and management all from one central device, essentially. So I'll get you to move on. Thanks, Brad. And so, yeah, just in summary, together with RFI and Morningstar's goods, we're really able to get a very comprehensive, fully fitted out solution that you can monitor and action on these remote sites. We're really making sure we can put together a solution for you where you're minimizing maintenance costs, where we're able to get a fully managed, fully maintained system where you can do as much as possible remotely to really cut down on those labor and travel costs. So all of the range of monitoring accessories that Brad went through today, there's a lot more to Morningstar's products than just the regulators themselves. They've got this wonderful suite of accessory products for monitoring that really take them to the next level. They make their compatibility with things like Modbus and SNMP really make them easy to integrate into industrial systems. And that's because Morningstar really it's a true industrial regulator. And it's really telling that they're one of the few that does offer such a wide suite of industrial protocols. So they're really designing to go into these mission critical industrial applications. And of course, that's where RFI really complements beautifully. And we have for 27 years now being able to provide that communications complement to Morningstar to really round out that solution and be able to provide both a monitoring and fully covered communication solution all in one from one vendor. And I think that rounds it out, Brad. So we can probably move on to the question segment.
Okay, great. Hey, thanks very much, Monique. Thanks, Brad. And thanks for everyone for attending. We've reached the Q&A session at this time. So just again, reminder, if you have any questions about what you've heard about, or if there was something that was not covered that deals with communications and remote monitoring, go ahead and text that question in. I did see a question that came in a few minutes ago, and the question, I guess this one is for Monique. The question is, how many digital inputs and outputs are on the MA2080?
That one's got 2 of each, so 2 inputs, 2 outputs.
Okay, very good. Well, thanks for that question. Thanks for the answer. While we're waiting to see if there's other questions that might come in, people might be texting as we speak. Just a question that I think comes up a lot regarding communications and remote monitoring these off-grid systems. I'll throw this one at Brad. Question is, when should somebody use HTTP versus Modbus versus SNMP for their monitoring?
Yeah, I can summarize that quickly. I mean, I guess with the HTTP connection, it's, as I refer to as a dashboard, it's the simplest and most straightforward, but it really just gives you kind of a shot in time. If you just need to know, what is this controller doing right now? It'll update in real time, so you'll always be looking at live data, but it's really a single point. With both Modbus and SNMP, they're more ideal when you're integrating it into some other system. Like, you may not be the direct viewer, but you're going to be communicating with a server, with a PLC, which Monique often mentioned that they work with as well, or you're working with a network management system where it needs to be able to talk SNMP because that's its native language. So in those cases, it's a little more tightly integrated. And again, Modbus leans towards industrial and oil and gas or SCADA applications. SNMP leads towards IT applications or those used for networking and security in terms of just industry adoption. Okay.
Okay, very good. That's very helpful. I see some other questions coming in here now. Question here is, are there other, this one is for Monique, are there other models with more input outputs or expansion modules for more input outputs?
So at this point, we don't. We are looking at a couple of options to bring in, though, that have up to 4 digital and some analog as well. So we are looking at some options at the moment for expanding that range.
Okay, very good. Very good. Well, thanks for that question and answer. I see a question here from Ian. This is a great question. It says, could you share, I guess this is more for Brad, could you share anything on how much you can oversize the array on the likes of TriStar and PPT before we run into any risk of damage?
Okay, yeah, well, first, one of the things is that it will not damage the product if you keep it within the power, a percentage of the power. Let me restate that. Generally, I would say about 130% is a good rule of thumb for oversizing. We find that to be the most efficient. There is not a physical limit. You cannot over voltage the product, absolutely. If the voltage of 150 is exceeded, you will damage the product, regardless of power. So as long as you don't over voltage the controller, which can cause damage, there is not a technical wattage limit. Of course, you're only going to get 60 amps of output no matter what. But generally, we recommend a good rule of thumb is 130%. It helps give more power on cloudy days. It will limit it on those hot days, and it just better utilizes the controller, you know, as a resource.
Right.
One comment on that is we do actually have other resources on our website, which you can probably locate, and we could follow up afterwards, that actually give you a little bit of a guideline on this type of rating, because I highly recommend the oversizing.
Okay, great question. That comes up a lot. So thank you very much for asking that. Here's another question for Brad. What's the number of input outputs on the relay driver?
Okay, so besides the meter bus connection to the controller, which we assume is taken, the 4 channels on the right side there are all can be used as either an input or an output. Okay, so they're 4, but you can only use them for one or the other, of course. So on the input, it's anywhere from battery voltage up to, I believe, 80 volts. So it can sense a voltage. Like if you wanted to look at an array voltage or the presence of another voltage in a system, you can do that. And then if you're using it as a relay driver or an output, it's limited to 3/4 of an amp. And I know that doesn't sound a lot, but it will actually drive pretty big relays, as I mentioned in my earlier comments. And I would encourage you, I don't want to go into all of it here, but take a look at the various logic options in the manual that it can handle.
Okay, very good. Another question, this one's from Monique regarding the MA2080. I think somebody else asked this as well, and I think you might have addressed this, but are there new versions pending of that product or anything similar?
Not of that specific product, but we are looking at some options as well that will have kind of similar I/O capabilities, but more Ethernet ports. That should be soon. But we're also looking at an option that doesn't really have the Ethernet ports, but does have a lot more of that I/O control functionality.
Okay, very good. Thanks for that question and answer. Let's see, here's a question about SNMP. So let's see, question is, has there been any discussion on integrating SNMP capabilities of the EMC, that's the Ethernet meter bus converter, into the network interface on the controller itself, so you can use both? You can use both RJ11 connectivity between multiple controllers and allow full remote SNMP monitoring as it stands, for example, on a MPPT TriStar 60 M. You can't do both.
Okay.
So Brad, you want to go ahead and address that?
Yeah, certainly. This gets into a very interesting area, and there's actually quite a bit with the architecture of why we did what we did, but I can summarize it briefly. The EMC was a gateway product and able to add this capability, and since it's not a charge controller, it's just that converter, it had a lot more capabilities in terms of its processor, running a web page, Modbus, and an SMP, all of which it can actually do simultaneously. You don't have to pick just one. You can ask any of those types of protocols all at the same time. We kept it external because sometimes it's needed, sometimes it's not, and we wanted capabilities for our entire product line. However, that being said, we are on a path to see these protocols and more of these software suite of features integrated into the charge controllers. It requires a little bit of a embedded architecture change to do that, but we are moving in that direction, and you're going to see a lot of exciting things in the future. And we think that the need for it is so great that it will be very much valued, having being built into the controller. More efficient, being able to talk to more products. So. Yeah, and feel free, you'll see our email here at the end. Feel free to reach out to me if you have any further questions about that application, because I'd love to discuss it.
Perfect, very good. I see another question. This question is coming in from Michael. Let's see. Question is, if you have multiple Morningstar controllers, can you operate them linked together so their output parameters are shown on one platform and communication input?
Okay, yeah, let's see, if all the controllers are tied together using, let's just say an example, the TriStar PPTs, using meter bus, that one meter will show a sum of all of the charging current. It'll show battery voltage, which of course is the same for all controllers. It'll show a summation of amp hours, load current, anything that can be added together that represents the system as a whole. Okay, now if you want to go further than that, you would need an external device, if you're using 45 or Ethernet, to combine those together. But there are many applications of data loggers and Modbus gateways that can do that kind of addition, PLCs and others. It just requires a little bit of logic, but the meter does it itself. And again, not to get too far ahead, but you'll see very soon a lot of newer capabilities on upcoming products that allow them to work in combination in an even more sophisticated way. So stay tuned for that.
All right, very good. I see we're coming up towards the end of the hour, but I do see another question that came in. Let's see. This question says, extracting statistics via SNMP from the TriStar MPPT60, we are currently using the EMC1 converter. Is there another way of doing the same without the EMC1?
Okay, and the question mark, was it for which product was it for? Did they say
this
specifically?
This is for the TriStar MPPT60.
Okay.
And it says extracting statistics using or via SNMP.
Via SNMP. Okay. One thing that's a bit in particular about the TriStar PPT is, even though it was the first product, not only the first MPPT, but many times the first charge controller that actually had native Ethernet. And this product was released some time ago. It's been a very popular product, and we appreciate the long life cycle of our products. As Monique said, we're very much in an industrial environment, so we want to see them around for a long time. It did not have native SNMP, so the only way to add the SNMP feature, which was on the MC that came much later in our product roadmap, was to then add it back to the TriStar PPT. Many people could be frustrated by this because they already had Ethernet. Why do I have to add an Ethernet adapter to a product that already has Ethernet? But it was for that SNMP capability. As I mentioned the answer before, though, we are aligning these features across our product platform so that you're going to see more consistency, more of these features, throughout the product line, and get all of the protocols in every Ethernet product going forward. So we do hope to enhance that, in the future with newer products.
All right, well, very good. I think that takes us to the end here. Looks like we answered all the questions. If somehow I missed anything, we will take a look at this again, and we will email you with a response if there was anything that we did miss. And likewise, if you want to reach out, you can see the thank you slide here. If you want to reach out to Monique or Brad, there's their contact information up there. So with that, I believe we can close things out. Brad and Monique, you want to say your goodbyes to the audience today, and thank you for the audience?
Okay. Monique, you first.
Thanks for coming, everyone. And yeah, as Mark said, if you guys have any questions, please don't hesitate to contact us.
Yeah, likewise. Thanks very much, Monique and RFI, for joining us for this collaborative webinar where we can both offer our solutions together because, the complementary is, the sum is greater than the parts. So we're happy to present this, and please do reach out if we can support you further.
Yeah, and thank you very much to Morningstar for organizing and hosting today.
Likewise, likewise.
Very pleased.
All right, we're going to close things out and we'll see you next time. Thanks so much for attending.
Thanks.
Take care. Bye-bye.
Thanks, everyone.